t cubed minus 6 squared plus 1, so I have to hold that place with a 0t. How many times does t go into t cubed? It goes in t squared times. T squared times t plus 2 will be t cubed plus t squared. Subtract gives me negative 8t squared. Bring down the 0t. How many times does t go into negative 8t squared? It goes in negative 8t times. Negative 8t times t plus 2 is negative 8t squared minus 16t. Subtract gives me 16t. Bring down the 1. How many times does t go into 16t? It goes in 16 times. 16 times t plus 2 is 16t plus 32. Subtract. I'm left with negative 31 left over as my remainder. And I create a fraction with that. Negative 31 over t plus 2. So my solution is t squared minus 8t plus 16 minus 31 over t plus 2. Just a word right here. If you need to go back and watch this a couple times, I wouldn't blame you. It's a complicated process, and there's lots of opportunities for little careless mistakes. You can see the negative signs and things like that can cause difficulties. So if you need to go back and watch it a second time, and even after we go over it in class, if you need to go back to this video to remind yourself of how to do it, please do so. More examples coming. Here's that other example I was promising you. Here I've got 2x cubed minus 5x squared plus 5x minus 2 divided by x minus 1. How many times does x go into 2x cubed? It goes in 2x squared times. 2x squared times x minus 1 is 2x cubed minus 2x squared. Subtract, and I get negative 3x squared. Bring down the 5x. How many times does x go into negative 3x squared? It goes in negative 3x times. Negative 3x times x minus 1 is negative 3x squared plus 3x. Subtract. I get 2x. Bring down the negative 2. How many times does x go into 2x? It goes in 2 times. 2 times x minus 1 is 2x minus 2. And when I subtract, I get 0 for a remainder. So my solution is 2x squared minus 3x plus 2. And that technique works for every time. There is a little bit of a shortcut, and it involves what's called synthetic division. And you can see here these two problems are the exact same problem. You can see this looks a little easier, and once you understand the technique, it actually is, but there's some interesting steps to it, so let me take you through it. Notice this, I've taken the 2x squared minus 5x plus 5x minus 2. I've taken that, and I've written down only, is it written down or wrote down? Right here are just the coefficients. 2, negative 5, 5, and negative 2. And instead of a negative 1 out here, just going to put the 1. Right, if I ask you what the solution was, if x minus 1 was one of the factors, one of the solutions would be 1. Right? Or if you just want to think of it as the opposite, that's fine as well. And so, and then I draw my bar, this bar right here. And that's the setup. And here's how it works. I bring this 2 down, sort of backwards from what we were doing. I bring this 2 down. And then I do 1, this 1, times this 2, and put it right there. And instead of subtracting, I'm going to add. -5 plus 2 is -3. 1 times -3 is -3. And then I add 5 plus -3 is 2. 1 times 2 is 2, and when I add, I get 0. And this last place value, this is always going to be my remainder. Right? It's always going to be, the last column is always going to be the remainder column. And changing these 3 numbers here back into like an equation with variables, this 2 is the 2x squared minus 3x plus 2. And you can see I've got the exact same solution I did before. So let me do some more examples of synthetic division. Here we go. 2x squared minus 5x minus 3 divided by x minus 3. I take the coefficients 2, -5, and 3 and write those here. I take the opposite of that number, the 3, or if this was a solution, the solution would actually be 3. And then draw my line. That's my setup. I bring the 2 down. 3 times this 2 is 6. Add, I get 1. 3 times this 1 is 3. Add, and I get 0 for a remainder. So this is 2x plus 1. And now 2 final examples. These examples will have remainders. Here I have m cubed minus 3m minus 7 divided by m plus 2. I take the coefficients 1, minus 3, and minus 7, put those right there. Take the opposite of that, put it there. Draw my line. Bring down the 1. -2 times 1 is -2. Add, and I get -5. -2 times -5 is 10. Add, and I get 3. And this last column again is my remainder column. So this is 1m minus 5 plus 3 over, and I got to go back to this denominator right here, m plus 2. 3 over m plus 2. And lastly, t cubed minus 6t squared plus 1 divided by t plus 2. Notice I'm missing a t term, so that's a 0t. So I take my coefficients of 1, -6, 0, and 1. Put them there. Going to divide by a -2, or a -2 goes right there. Bring down the 1. -2 times 1 is -2. Add to get -8. -2 times -8 is 16. Add to get 16. -2 times 16 is -32. Add, and I get -31. And that -31 and that t plus 2 become -31 over x plus 2. And yeah, I switched from t's to x's, and that's not a big issue. So my solution, 1x squared minus 8x plus 16 minus 31 over x plus 2, and yes, there should be t's.